Greetings, sir. Today I will be presenting our Semester 2 design project titled Multifunctional Safety Helmet, a conceptual design for modern mining operations. The main purpose of this project is to improve safety in underground mining and environments using modern smart technologies. Our team focused on combining protective equipment with real-time monitoring systems so that the helmet not only protects the worker who's going to the underground mine to work, but also it would helps detect dangerous environmental and health conditions before accidents would occur. And if you have to talk about our project scope and objectives, the primary goal of this smart helmet is to reduce mining accidents by approximately 40% through real-time environmental and biometric monitoring. And I'm proud that we achieved the particular criteria in our project. The target users of this helmet are underground miners and heavy machinery operators working in high-risk excavations. Our main focus areas were specialized head protection, second, environmental sensing, biometric monitoring, wireless communication systems. We just wanted to design a helmet that would act like it's a shield to a person who's willing to do the riskiest work of his entire life. So we just wanted to prove that we really made something very unique. And if we are moving to context and the environmental challenges we faced, that a miner could face, and that would be and one major issue would be accumulation of toxic gases such as methane and carbon monoxide. These gases can become life-threatening if someone gets to inhale them. So fatality, you can't fathom that fatality. So another issue is the presence of high dust levels and extreme heat, which can cause breathing problems and heat exhaustion and even mental fatigue. So to solve these problems, we integrated MEMS gas sensors into the helmet to detect methane and particulate matter in real time. We also included biometrical sensors to monitor body temperature and pulse rate so that signs of fatigue or overheating can be identified very early and very quickly, so that the person who's going to the mine doesn't have to worry about a single thing, that whether toxic fume would be leaked or whether I will inhale and die. No, there's no place for that, and we are proud that we eradicated that idea. And if you have to talk about the requirement analysis, first the atmospheric sensing system needed to detect harmful gases like carbon monoxide, hydrogen sulfide, and methane with less than 1 second of delay. Second, the helmet had to meet ANSI or IECA G01 Types 2 safety standards for impact resistance. We also required a minimum battery life of 12 hours because that's the typical or average time a miner would work in underground, and a lightweight construction for user comfort, plus the strong and durable materials for harsh mining conditions. These requirements helped us decide the materials and technologies used in our final concept of this helmet. And next we go to design alternatives, because what if this doesn't work? So we had to make 3 additional or alternative ideas. So we categorized them into option A, option B, and option C. And option A was a hybrid design using a traditional ABS plastic shell with external clip-on sensors. Although it was cheaper, it increased the helmet's weight and reduced the integration. Option B was the integrated smart helmet design using a carbon fiber shell. Then carbon fiber shells are like really durable, so we can rely on them, with embedded electronics and an augmented reality visor. This was our selected design. Option C was a minimalistic concept focused mainly on lighting and communication features. It was lightweight but lacked important safety monitoring system, because what if the fume get released and a delay was there and the person chances of him getting suffocated is there. So we didn't want the plan C to get the spotlight, so we kept it as an option. After comparing all these concepts, we selected option B because it provided the best combination of safety, functionality and efficiency. And next we move to our concept, the modern miner concept. Our helmet uses a high-strength carbon fiber shell combined with a non-Newtonian impact liner. As you know, sir, a non-Newtonian material behaves softly under normal conditions but hardens instantly during sudden impacts, and that's what we really want, and we achieve that in this project, because this improves energy absorption and provides better protection to the worker. The helmet is powered using an ESP32S3 microcontroller which manages sensor data processing and wireless communication simultaneously. This allows the helmet to function as a smart integrated safety system instead of just protective equipment. And next we move into our technical components. So I'll be explaining some of the major technical components used in our finalized design. So the helmet includes an ESP32S3 dual-core microcontroller with Bluetooth and Wi-Fi mesh support. We also proposed a transparent OLED heads-up display or HUD which allows workers to receive warnings and navigation information directly with their field of view. The carbon fiber shell, which is the major part of our design, provides both durability and lightweight performance, improving comfort during our long working shifts. These components work together to improve worker awareness and communication underground, and communication is the main core important thing that we really need. And next we move on to our performance metrics. How you would expect our helmet to work, what are their to which distance it would go, how could it be useful. So this slide highlights the key performance specification of the helmet. The helmet uses a 3000 mAh lithium polymer battery capable of operating continuously throughout a full work shift. We also included a 1000 lumen adaptive LED headlamp for improved visibility in dark mining environments, because you can't be mining only in the daytime, right? Even if it's a daytime, it will still be dark in the underground. So we had to adapt this lumen LED headlamp. Additionally, the helmet provides 360-degree sensor coverage for complete environmental monitoring. The battery casing is designed to be fireproof and impact resistant, while also improving the helmet's weight balance for better ergonomics. And we'll move to full functionality of our safety helmet. First, the environmental monitoring system continuously detects hazardous gases like methane, carbon monoxide, and hydrogen sulfide. Second, the biometric tracking system monitors the worker's pulse rate and body temperature to reduce risks related to heat exhaustion. Third, the transparent HUD displays safety alerts and navigation instructions in real time. And finally, vibration motors provide silent emergency notifications, which are especially useful in noisy underground mining environments where sound alarms may not be heard clearly. And we move on to the additional safety features. And in addition to monitoring systems, we also included several advanced safety features, because why not? The helmet uses a carbon fiber shell and non-Newtonian liner to improve impact protection and satisfy ANSI safety standards. For communication, the helmet supports Wi-Fi and Bluetooth mesh networking, allowing workers to stay connected underground. We also included, additionally, a top-mounted warning light cluster, a rear warning strobe, and a 1000 lumen adaptive LED headlamp. These features really improve the visibility and communication during emergency situations. Yes, and then we move on to implementation timeline, how many months or weeks we took to create this prototype. From week 1 to week 3, we focused on conceptualization and component research. From week 4 to week 6, we carried out technical design, development and safety analysis. Finally, during week 7 to week 8, we completed evaluation and presented our final documentation. This timeline obviously helped us to organize the project systematically within the available semester duration. And then we move on to the limitations there will be and its future work. Although our concept is a bit promising, there are still several limitations that we have to discuss. One major limitation is the high manufacturing cost, which is estimated to be about 3 times higher than our conventional helmets that our miners use these days. Another challenge is to signal interference caused by thick underground mineral deposits, which can affect communication and positioning systems. In addition, the sensors require periodic recalibration to maintain accuracy because that's the maintenance phase. So it really requires the periodic recalibration. So for future work, we hope to develop a physical prototype and further improve communication reliability in underground environments, because that's the only criteria we fell short of, and we really think we can improve on that particular thing. And then we move on to our sustainability and social value. We propose the use of recyclable materials and modular battery systems to reduce electronic waste. From a social perspective, improving miner safety can reduce insurance costs, improve worker confidence, and provide peace of mind for workers' families. Because everyone would be scared, like if their son or daughter is going to the mine. So we are concerned, like we really should give them a perfect prototype. Overall, the project aims not only to improve safety, but also to improve the overall quality of mining operations. And to conclude, this project successfully combines mining engineering, IoT technology, biometrics and material science into one integrated smart safety solution. Although we could not develop a physical prototype due to the time constraints we had, also because we had our semester end exam coming within 2 weeks or 3 weeks, so we really didn't have the time to build a perfect 3D prototype. Physical prototype due to time limitations, and we believe the concept is technically feasible and commercially valuable. And that's about it. Thank you so much for listening, sir, and we accept feedbacks and for the discussion.